3D models should always be created with optimization in mind. In this module, we will learn about some of the general requirements to consider for any 3D models that we will want to import into our project. There are a few general characteristics that we should keep in mind for any geometry that we model or import into Unreal Engine. Broadly speaking, we want to keep our models as low poly as possible without sacrificing visual quality. We want to minimize the number of material channels that we use per object. We should avoid unnecessary tessellation in our models. And when possible, we should use opaque geometry instead of masked materials. Here's a model of a house that was first created in Autodesk Revit, then imported into 3ds Max where it was then modified. We can see that a fair amount of detail has been added to the model. At first glance, nothing appears to be exceptionally high poly, smoothing and normals appear accurate, and it doesn't appear that any of the models have really complex materials that could cause a problem. To optimize this house model for Unreal Engine, a great deal of attention has been put into how the geometry is set up. Notice that all of our walls and floors terminate right at corners. If we choose to build our lighting in Unreal Engine, this will help us to have nice, crisp shadows along these surfaces. Also, notice how some of these ledges and half walls have a rounded lip. This will help catch reflections and lighting to make it seem much more realistic. To give us even more resolution to work with for our light map UVs, all of the back-facing geometry has been removed from the walls and floors. There's no need to include those faces if they'll never be visible to the user in Unreal Engine. Before we import this model into an Unreal Engine project, we need to verify that all of the UV maps are properly created for all of our geometry. We need a UV map for the material, as well as a UV map for the light map that we could use later on for baking our lights. Although, this can be automatically created in Unreal Engine when we import our models. Take a look at the material applied to the pool here. The tile is a good scale, it isn't stretching, and it appears to be rotated correctly. This model already has proper UV maps applied, but we'll learn more about how to correctly create UV maps later in this course. In this module, we learned about some of the various requirements that we should keep in mind for 3D geometry. Remember that effort we put into optimizing content early in the process will ultimately prove beneficial to our runtime performance in a real-time application. Next,